hopefully you have questions so that this live stream is exciting and interesting. Go.
31.
31. Guess I should go get a calculus book. We 4.4?
Yeah.
By the way, I'm finding myself talking about different things in the other classes just because they have different questions. And there tend to be lots of good questions in both. So you may find it interesting. The live streams are fairly short for calculus because, you know, I shut them off as soon as the questions are answered. You may find it interesting to watch those and just get different perspectives. I highlight different things, and you're more than welcome to do that. A line with slope m passes through the origin and is tangent to some function. Okay, so here's the deal. I don't care what the function looks like, but there it is. And there's a point on the function. And I've got a line that is tangent to that point and goes through the origin. So I know that the origin is at 0, 0. And I know that this point is at A, comma, B. So do we agree that the slope of that line is B minus 0 divided by A minus 0? Okay. So let's talk about A and B. This is A, and B is technically f of A, agreed? But the function is natural log of 2x, so that point is technically A, comma, natural log of 2A. Agreed? So the slope is now natural log of 2A minus 0 divided by A minus 0. Are we in agreement that zero calculus needed to answer this question so far? I have not used one speck of calculus. In fact, I think we're all the way back at algebra, slope of a line. The only thing about algebra is I don't know what that ln thing is, but you know, fortunately we do. Now let's talk about calculus. Y equals natural log of 2a. Y prime is equal to, what's the derivative of natural log? Anybody?
1 over x.
1 over x times chain rule. Derivative of that, which is 2. Fair enough?
Yeah.
But wait, isn't that the slope of the line? The derivative is the slope of the line. Oh, so you mean 1 over a must be equal to natural log of 2a over a? Which means that that must be equal to 1. And then I can figure out what value of a would make that true. That make sense?
Yep.
You guys know how to solve that? E to the power of.
Yeah.
That's how you solve a natural. Yeah. So you solve a logarithm, is you change it to a. I remember the circle of success.
No.
Y equals log base b of x. B to the y equals x.
Why is it called the circle of success?
Because if you go around in a circle, you will always be successful. Mr. Brannon came up with that as a joke, and he was telling his Algebra 2 classes that this was the circle of success, and they were all just like, and then I said, hey, that sounds sort of cool, so I started doing it in my class, and everybody loved it, so I went back to Mr. Brannon, and I was all like, dude, everybody in my classes thought that was hysterical and awesome, and they were all like writing circle of success in their notebooks, and I would say to them, how do you solve a logarithm? Circle of success. I think I think it's more just a matter of how you present it as opposed to how silly the idea is, but it helps people remember it, so. All right, we good? Everybody know what e to the natural log is?
1. Well, they cancel out.
They cancel out, yeah. They're inverse functions, so this is 2a is equal to e to the 1. So let's sort of go back and analyze this problem a little bit further. 1, we're told a slope through 2 points. Be watching for that. When you see a problem that says a slope or a line that goes through 2 points and it says something about slope, you immediately know you've got 2 things. Thing 1, traditional definition of slope. Thing 2, derivative definition of slope. So we're taking algebra and calculus and saying, hey, let's do the thing from algebra and let's do the thing from calculus and set them equal. Boom. Since they're the same thing, we solve a problem. I don't know why there's a 1 on that, because there's no 2. That's okay. You have a list with 1 thing. Guys, this is sort of key moving forward, not this particular problem, but key moving forward in advanced mathematics is a lot of advanced mathematics is looking at a problem and saying, how can I relate this to something I've done before? Which may not be like totally obvious that I need to relate it, but that's what most advanced mathematics is. You look at a problem and you say, oh, this problem is so complicated, I don't know how to do it. Well, is there a bit of this problem that I could do by doing something that I did with a previous problem? Oh, look. And in this case, you see, hey, look, I see the word slope, and I know 2 different things about slope. Boom, off you go, you've solved the problem. And you're going to find that a lot as you move forward, that it just really boils down to, what do I know from previous problems? So when you're looking at any problem, don't look at it as a brand new problem. Try breaking it into bits where you know, where you've seen it before, and then solve that bit. Sometimes you'll get nothing. Sometimes you'll discover that, in fact, your solution leads nowhere. But that's okay, because now you've filed away a little bit more knowledge, and then next time you see a problem like that, you'll be like, oh, hey, you know what? I can't do this because that doesn't work in this particular case. Okay, good, I won't do that. All right, what else you got? Did you guys notice that I made a quick chapter 4 recap video and put it up on Friday? Chapter 4 doesn't have a whole lot of stuff in it. There's some derivatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And there's some strategies. The strategies being chain rule, logarithmic differentiation, and the other one, which is in the video. So there isn't much to chapter 4. Chapter 4 is just a lot of doing the stuff we've done in the past over and over and over again, and hopefully that's helping. Hopefully by the end of chapter 4, I mean, not only have you learned more derivatives and a couple more strategies, but really lots and lots of practice of how to just do the things that we've done before, which is why I like chapter 4. It's sort of a nice little take a breather from new concepts and just do derivative problems over and over. Logarithmic differentiation, I mentioned this in the video, but everybody always forgets about it. And so, hey, let's talk about it over and over and over again so that you're less likely to forget about it. Logarithmic differentiation is pretty straightforward on how to do it, but where people get lost is when to do it. Logarithmic differentiation says you've got some function and some function, and what you do is you just take the natural log of both sides and then you do the derivative. And then derivative. That's all it is. Really, really easy, straightforward question. But the more important problem is, why would you do logarithmic differentiation? You do logarithmic differentiation anytime you got y equals some function of x raised to some function of x. Because we don't have a rule that says, how do I take that? If it's x to some number, then the derivative is just the number x to the number minus 1. That's the power rule. If it's the derivative of something to the x, well, then it's just the natural log of the number times a function. But if it's a function raised to a function, we don't have a rule. This doesn't work because that's not a number. This doesn't work because that's not a number. So by taking the natural log of both sides, and I skipped a step here. You guys see the step I skipped?
Derivative on the y.
No, I haven't taken any derivative yet.
Oh, yeah.
The step I skipped is taking the natural log of something with a power allows you to just move the power out front. Remember that? Natural log, or log of a to the x is x natural log of a. That's a natural log. Remember that? So now I can take the derivative. Over here, I'm going to use implicit differentiation. I'm going to take the derivative of that side. And over here, I use the product rule. U times V. And then I can solve for that because I'll get y times squiggly push. But then y is equal to that, so then this becomes the original function times squiggly push. This is what you need to remember. Function raised to a function, take the natural log of both sides, and then start taking the derivative. All right? Cool. All right, what else? Ask me questions. Let me look at emails and see if I got any emailed questions. I don't, not yet. Hopefully people watching the live stream know they can email me questions. If they didn't, they should now, right? Claire. Louder?
Number 23.
Number 23, I would love to. Sorry. Noise from outside. There, I'm gonna shut this. I discovered something interesting the other day. I had somebody talking on my live stream, and I was back at my desk talking to one of the tech guys, and this microphone picked up our whole conversation. It was an amazingly sensitive microphone. Wouldn't mind tuning it down, but I haven't played around. 23, y equals log base 2 of 1 over x. Where would you start? What kind of problem is this? True. But it's a log of a function, right? Which makes it what kind of problem? Chain rule. Agreed? If I set u equal to 1 over x, this becomes y equals log base 2 of u. So the derivative of y with respect to x is, how do I take the derivative of log base 2?
Isn't it 1 over natural log of 2?
1 over natural log of 2.
whatever you.
You can also, in the book, they usually write this natural log 2u, but I sort of like to separate them out so I remember that this is the conversion factor for being a log base 2 instead of a natural log. Times, chain rule?
One.
Yeah.
U is not one.
Yeah.
Oh,
Chain rule says times the derivative of the inside of the grid.
I know this is just 1 over x for you. I wasn't paying attention.
So, how do I rewrite that in order to find the derivative? Boom. Agreed?
Oh.
Power rule. So this becomes 1 over natural log of 2 times 1 over x times negative 1 over x squared. Agreed? But 1 over x is? Do some simplification. That's interesting because the 1 over x, apparently the only difference between the derivative of log 2 of x versus log 2 of 1 over x is you stick a negative 1 out front. Otherwise, that's the exact same derivative as log base 2 of x, which I find sort of interesting. Logs are just generally interesting.
I'm sending to you every day.
What's that?
So that's why I send it to you every day.
Surprisingly, because logarithmic scales are interesting. When you scale something logarithmically, it does interesting things.
I was making a pun, you know, like log, like wood.
Got it. All right, what else? More questions? Okay. Then the quiz is going to be posted up tomorrow. I think as soon as class ends, it will be. I think I scheduled it to just happen when class ended. I recommend you do it as soon as possible because if you guys do it quickly, I can grade it and get it back to you. And then you'd be able to email me questions before the test, which is going to be open on the weekend. And I know these are coming fast and furious, but I just I couldn't figure out a way to schedule it where this garbage with you guys being here 2 days a week is so annoying. But I really, really, really want you to learn as much calculus as we can, given the restrictions. So get the quiz done as quickly as possible. Don't forget, put it in your calendar. It shows up in your school calendar, but make yourself a note, reminder, do calc quiz. I'll get them graded and back to you pretty darn quick as soon as I see them. And then on Wednesday, Thursday, please feel free to come into the live stream. Please feel free to email me questions. You can email me questions. I mean, you can just email me the same kind of questions y'all asked me in class here, which is, hey, could you go over problem such and such? And to make sure you tell me it's the review or 4.4 or whatever. I'll assume it's the review, but just shoot me emails if you're watching the live stream, and I will keep an eye on that, and I will answer them. Because I feel a little bit bad that there's no more opportunities now for you to ask questions other than that. But we got tomorrow, and we got the Wednesday, Thursday live stream. So, and then the test will be available all weekend. Again, I'm just going to have it. I think I've got it scheduled to drop as soon as calc class ends on Thursday morning. So you should have the test by 9:05, and you'll have till Sunday night to do it. And then we'll start talking about chapter 5, which is more fun stuff. Actually, chapter 5. Oh yeah, chapter 5 is interesting.
How close are we to like calculus 1 material?
How close are we to what?
To like finishing calculus 1 material.
So you're talking about like the Everett
Yeah.
community class, college stuff. So we're getting close. The way college calculus works is 1 is derivatives and 2 is antiderivatives. And so without diving into the curriculum that's been laid out, we've sort of done this, and then the next section that we're going to do is something called the mean value theorem, which has to do with derivatives. So I want to say that from a perspective of where are you college class wise, probably by spring break we'll be approaching being completely done with first quarter calculus. I know that a couple of you took first quarter calculus at Everett, but I don't remember who. Did you? Signed up at Everett? Was it you? Okay. So if you sort of felt like just moving on when you got to college, I think you'll be fine. I think you have no problem going straight into second quarter calculus. And we will cover some of second quarter calculus. But of course, the problem is that we'll have 4 weeks to do it.
Yeah.
So basically, you'll get an introduction to antiderivatives, and that's about what you'll get. I think what that means is that for any of you, and I mean it's tougher if you don't have the credit, of course, but walking in, I think first quarter would be super easy for any of you to walk into college and just do derivatives again. And you'd be like, hey, I'm sort of bored, but I'm going to get a 4.0, and then boom, my GPA benefits. It's nice to have a 4.0 in the first quarter so that if you get a 3.9 in the second quarter, yeah, great. But I think that any of you walking into second quarter calculus at any college would have a pretty good idea of what was going on and not really struggle. And you'll have a decent intro to an antiderivative. And so when they start talking, you'll know what they're talking about.
Okay.
Yeah. All right. Any more questions that you want to ask? Okay, I'll leave you to it. I'm not seeing any emails, so nobody at home has asked a question. I'm going to go ahead and shut down the live stream. And you guys can work on problems, ask me questions privately, or just get work done, and it's all good.